Okay, so hello everyone. In this video, what we want to do, or what we're gonna do rather, is getting into equations of secant lines and tangent lines. I have done a video on this, except it was just kind of, I kind of went a little too far, or a little too, in depth with the definition of secants and tangent lines. I'm gonna just go very briefly on what both of them are, okay? So when you have an equation, or when you have a secant line, I'm just gonna do this very quickly. Let's say you have a curve, so I don't know, let's say, let me just use this color. Right, and the thing about this is, so the definition of a secant line is that the graph touches any 2 points. So basically, let's say this one and this one. Okay, so if you make a line between those 2 points, right, like that, right, that is what we call, and actually let me just position it a little better. It doesn't have to be perfect, but basically any 2 points that the line crosses at, so kind of like this is what we call a secant line. So I'm gonna do an example of that in this video, and I'm not gonna get into tangent lines just yet. I guess I'll just do this video specifically on secant lines. I don't think I should do both, because secant and tangent, because again, I don't want to do too much in one video. So I'm just gonna go ahead and do a problem. So for example, let's say we have a problem, and give me 1 second, guys. Okay, so this is a secant line, right? So basically, let me just explain this, okay? This is what we call x1. This is what we call, or actually, hold on. Well, yeah, this is what we call x1 here. Here is y1, and then this is x2. So let me just kind of color code here. This is x2, y2. So basically here, this is let's see, hold on. This is what we call y2. All right. So the equation of the secant line, if we want to find the equation of the secant line of f of x from the interval a to b, then let the slope of the secant line be defined by, and we're going to do m sub secant. So the slope of the secant line, this is how we read it. M sub secant is equal to, and it's going to be f of b minus f of a over b minus a, where b minus a does not equal 0. Okay, So what exactly does that mean? That means from this interval here, we can find this slope, right? So this is the change in x, this is the change in y, and this is x1, y1, and this is x2, y2. Okay, that's what that means. And we can find the slope between those 2 points on this curve here that is defined by f of x, okay? So let me just explain. So basically, let's do an example, okay? For example, let's say we have this, so I put this as number 13 on my binder here, or my notes. It says find the equation. So let me write this problem down very quickly. So find the equation of the secant line. Oops. Find the equation of the secant line on the interval from 1 to 3 of f of x equals x squared minus 3. Now we already defined what the slope of the secant line is, but we want the equation of the secant line, right? Now the equation of the secant line is going to be defined by the following formula. It's going to be y minus y1 equals the slope of the secant line, m secant, right, times x minus x1. Now, this interval here, when they give us an interval like this is in terms of x, and that means that this is x1 and this is x2. So basically, from an interval, we can do, actually, let me write it this way. For those of you who don't like this notation, I can write it this way. From x1 to x2, and then let the slope of the secant line be defined as f of x2 minus f of x1 over x2 minus x1, where x2 minus x1 does not equal 0. So I can do it that way, if that helps, if it's easier, right? But it's the same exact thing that we're doing. It's an interval, really. It's in terms of x. The interval, anytime they give you an interval like this, it's always going to be in terms of x. For any, whenever they want to find a linear equation between any curve, unless it's like a, or actually, no, yeah, it's always going to be in terms of x, this interval here. So, how we're going to do this one, so we want to write the equation of a secant, or the slope of the secant line, f of x2 minus f of x1 over x2 minus x1. We know what x1 is. x1 is 1, and x2 is 3, right? And basically, we know that, so we have to find what f of x2 is. F of x2 is really just f of 3. So that's going to be, so f of 3 is the quantity 3 squared minus 3. Let me color code that. Is really just, so 3 squared minus 3. So we have f of 3 equals 9 minus 3. F of 3 is equal to 6. So that's what f of 3 is. That's what goes right here. And let me rewrite this. Let me plug in x1, x2, and x1 and to these numbers here. So m secant is going to be defined as f of 3 minus f of 1 over 3 minus 1. We can solve the bottom, so the slope of the secant line is going to be equal to f of 3 minus f of 1 over 2, really, because 3 minus 1 is 2, right? So that means that the slope of the secant line is f of 3, so it's going to be 6 minus, and then we have x1, so f of 1 is 6 minus 1 over 2. That's going to be oh, and I'm sorry, hold on, my bad. Not 6 minus 1. So now we have to find f of 1, so we have 6 minus f of 1 over 2, and we have to solve for f of 1. So what is f of 1? We know what f of x is. F of 1 is going to be the quantity 1 squared minus 3. So we have 1 minus 3, that's negative 2. So that's what f of 1 is. And let me color code that. So obviously we know that f of 3 is 6, and so f of 1, f of 1 is going to be negative 2, right? So then we have the slope of the secant line is 6 minus negative 2 over 2. So then the slope of the secant line will be 6 plus 2 over 2, which is 8 over 2, which is 4. So that's what the slope of the secant line is. It's 4. Now, rewrite the formula, and the formula that we have, or actually, hold on. To find the equation of the secant line, it's the following: y minus y1 is equal to the slope of the secant line times x minus x1. And we know what x1 and y1 are. We noted that. x1 is 1, and so basically x1 equals 1. y1 is going to be, so y1, basically f of 1. So this is y1 because basically when, so in any equation, it's like I said in the definition here, wherever x1 is, that means that y1 is just going to be the output of that. So basically y1 is whenever x equals 1 in f of x. So if we found f of 1, and it was negative 2, so y1 is going to be negative 2. Please let me know if that makes sense to you guys. If it doesn't, I'll try my best to explain it more. But yes, that's how you would see it. So then it's going to be y minus, and then we have negative 2 equals, so it's going to be, so the slope of the secant line is 4 times x minus, and then x1 is just 1. So then our equation ends up being y plus 2 equals 4 times x minus 1. This equals y plus 2, or rather, if we subtract 2 on both sides, we get y is equal to 4 times x minus 1 minus 2. So then y is equal to 4x minus 4 minus 2. So y is equal to 4x minus 6. And we can prove that by graphing this, right? If we graph this function, so if we graph both functions, we can prove that this is true. We can prove that this is the equation of the secant line between those two functions. And let me just show you guys how this would be done. So, trying to see exactly how to do this. Hold on. So, okay. Give me 1 second. Meanwhile, I actually draw the graph. Okay, so, the way that you would do this, and, let me just, so, okay, the way that you would do this is, first you need to graph f of x is equal to, and we have the original equation, x squared minus 3, right? Now, this is if they want you to show that it's true, like if they want you to show a graphical representation of this. You don't have to do this if they don't ask you for a graph. This is just to show you guys that this is true, okay? If we do, so basically, if we do x squared minus 3, in reality, the vertex is 0, negative 3, because anytime you have it of the form x squared minus c, or plus or minus c, the vertex is just 0, comma, plus or minus c. That's just how it is. Let's see. So, when we evaluate at x equals 1, 1 squared minus 3 is 1 minus 3, so it's negative 2. And if we evaluate at x equals 2, 2 squared minus 3 is really just 4 minus 3, which is 1. And if we do 3 squared minus 3 at x equals 3, that's, well, yeah, that's 6, because it's 9 minus 3 and it's 6. I was going to put 9 minus 3, so it's 9 minus 3 and then it's 6. So it's like this. And then you want to do the reflection, so it's going to be 1. So the reflection is going to be like this. And you graph it like this. Hold on. 1, 2, 1, 2. And then 1, 2, 3, 1, 2, 3. So then you're going to draw a smooth curve, which represents the parabola, or the equation of x squared minus 3. And it doesn't have to be perfect. You can just draw a rough, kind of like a rough sketch of it, like this. Okay, and then to do the secant line, you're just gonna do 4x minus 6, and that's a linear equation. So we all know that the y-intercept is 0, negative 6, so it's right here. And let me actually do this in a different color. I'll do this one. And then we do 1, 2, 3, 4, 1, 1, 2, so it's 1, 2, 3, 4, 1, and then it's 1, 2, 3, 4, 1. So surely enough, if we draw a line, a straight line between those 2 points, we can see very clearly that the points here, so this is, so actually hold on, this is x1, y1, this one right here, and then this one, or not this one, this one is x2, y2, okay? And that is how you find an equation of a secant line between 2 points. You just have to find, it's really just the slope between those 2 intervals. It's really just giving you, like, the slope between those 2 intervals, and you just have to plug x1 and x2 to this equation, and you have to use this formula here to find the slope of the secant line, and then you have to find this equation here, this formula here for the equation of a secant line, and that's how you do it. And as you can see, I was right, because here is where 1, -2 is located, and over here is where 3, 6 is located. And like I said, we wanted to find the equation of the secant line on the interval 1 to 3 of this equation. And we graphed both of them, and we made a graphical representation of how that is true. So, I'm gonna stop the video here, guys. If anybody has any questions about this one, let me know, or like if you have any questions about how to find an equation of a secant line, let me know any questions, and in the next video we are gonna do, and I only did one example because obviously I was defining what this is, right? But if anybody has any questions, please let me know. But this is what a secant line is, and we went over it at the very beginning when I did this, right? When we did this part. So like I said, if anybody has any questions, let me know. Please like, comment, and or subscribe, and I will see you guys in the next video. Thank you so much for watching. Bye, guys.